Hello everyone, today I'm going to discuss about the hack CPU architecture. The hack CPU diagram includes the 3 inputs and the 4 outputs. And inside the CPU, there are several registers such as A register, D register, ALU, or program counter. So in order to understand the hack CPU diagram, firstly, for time being, we will forget what is inside the CPU. So in this diagram, there are 3 inputs and the 4 outputs. Instruction, in M, reset are the inputs, out M, write M, address M, and the PC are the outputs. So in order to understand the hack CPU diagram, from where the inputs are coming and where the outputs are going, we will understand the following diagram. So in this diagram, the CPU is connected to the instruction memory as well as the data memory. From the instruction memory, a specific value of instruction is being input to the CPU from the selected instruction memory, from the selected instruction memory register. The next input is in M, which is the input data of the selected memory register. The next input is reset. Reset input is a value that tells that whether to bring the CPU back to the initial state when the reset value is equal to 0 or to start the CPU from beginning when the reset value is equal to 1. So now we will talk about the outputs generated by the CPU, which are write M, out M, address M, and the PC. The out M stores the value of the M register, which has a specific location as address M. The PC is the program counter, which holds the address of the instruction, which will be fed, decoded, and executed. Coming to the code section, the code consists of 2 sections, the header section and the part. The header section include the chip name, the input pin, and the output pins. Inside the input pins, there is in M of 16-bit, instruction of 16-bit, reset. And inside the output pins, there is out M of 16-bit, write M, address M of 15-bit, and PC of 15-bit again. Further, the part section include the rest of the code, in which there are firstly 3 different gates: NOT gate, AND gate, the MUX16 gate. These different gates are used by the CPU to perform specific operations. There are 2 types of instructions as coming from the input from the instruction memory. Either it will be A instruction or C instruction. Now, what are A instruction and C instruction? The A instruction has a syntax @value, where value can either be a non-negative decimal constant or a symbol referring to such a constant. According to the outcome, for an example, @12. So the A register will set to a particular value, which is 12. Moving further, the C instruction has syntax destination is equal to the computation or jump. Both destination and jump are optional. The computation is the function to be performed by the CPU to give a specific result. The result is stored at the destination. The jump is used to jump an instruction to jump into an instruction based on the computation. Now in this, the 2 NOT gates determine whether it is an A instruction. The AND gate determines whether it is an C instruction. The MUX16 is a selection will select either the A instruction or the ALU output, which will go to the A register. As you can see in the above diagram, the A register can be fed by either the ALU output or the instruction input. If it is an C instruction, then it will perform the computation in the ALU, and the ALU output is fed to the A register. Now there is an OR gate. The load will be equal to 1, in which if an instruction or the ALU output is fed, whereas A register is used to store the value. In Mux 16 gate, the Mux 16 gate, which takes the input as the value of A register and the value that is currently selected in data memory. The selection will be based on the 12-bit instruction value. The ALU output is loaded into the D register, and the D register is implemented to load and store the value of the D register from the ALU. In next line, ALU is used to calculate the computation. Inside the ALU, there are several control bits such as X, ZX, NX, ZY, NY, F, NO. These control bits are used to tell us which function will be computed. In the next line, there are 2 OR 16 gates and AND gate. The first OR 16 gate tells us the address of write operation, and the second OR 16 gate tells the content of data memory. And at last, the AND gate determines the output. In the next line, there are several lines of code which determine the jump conditions and checks the ALU output to see if the conditions are met.